Hello, my name is Jared Skeens and welcome to the Zoom room. This is the beginning of the Cambridge Pure Maths 3 video series. So today we would like to look at Pure Maths 3, Further Algebra, Part 1, Modulus. So in Modulus, we want to look at several different things. We want to look at inequalities. We want to look at one-sided modulus, where modulus is one side but not the other. And then we want to look at situations where the modulus is on both sides. And a little bit later, we'll look at sketching a modulus equation. But first of all, let's start with the concept of what is modulus. Some people might call it absolute value, but basically what it represents is distance or displacement from the origin or from a point of reference. So if you notice that here is 0 on our x-axis number line, and we have the number 3 and the number -3. And really the only difference between the signs of a positive 3 and a -3 is the sign provides direction. So a positive 3 is to the right along the x-axis, and negative would be to the left from our origin. But both of them have something in common. That is, both of them are the same distance away from 0. So 3 is 3 units away from 0, and -3 is also 3 units away from 0. So when we're talking about modulus, we're talking about that absolute value as a distance, and distance is always positive. So the outcome of what's inside that modulus, the outcome will always be a positive number. So the absolute value of 3 is 3, and the absolute value of -3 is also 3. So in having this in mind as a concept, let's go back and look at these 3 different situations that we're going to run into. First of all, the inequality. What is the difference between the equal sign and the inequality? Well, first off, notice the positive side doesn't change. It's 3 on the inside, it's 3 on the outside. Same thing with an inequality. You have x less than a, and so you get x less than a as one of your 2 outcomes. The other one, though, has a negative on the inside, and then that negative disappears. So when we're solving a modulus, basically what we need to do is we need to take the negative of the other side. And when you take the negative of the other side, if you remember your inequality rules that involve multiplying or dividing by a negative, it flips the inequality. Same thing here. When you're dealing with the negative part of the modulus, it flips the inequality. So this becomes x greater than, you read it from the variable, x greater than -a. So you flip the inequality and you apply the negative sign. So this joint inequality statement now shows both sides of the modulus. X is less than a and x is greater than -a. Moving on to one-sided modulus equations means that you have that absolute value sign on one side but not on the other. So the best way to do this one is to separate, just like we did up here, to separate into our positive and negative statements. So we take our x minus a, which is inside the modulus, and we go less than b, that is the positive statement, x minus a less than b. And then we take x minus a, flip the inequality, x minus a is greater than -b. So we distribute the negative over here. So here we have our positive and our negative statements. And so when we have one-sided modulus, we're going to separate them into the 2 parts. From this point, you can then solve for x with both statements. You can split this joint inequality into two separate inequalities and solve them separately. Then we get to both-sided modulus, where the equation has an absolute value on both sides. So what we're going to do here is we're going to square both sides of the equation. And because you're squaring it, that plus and minus won't matter anymore. So if you have an inequality, you're just going to leave the inequality the way it is. When you square, all your plus and minuses turn positive anyway. And so we're going to square both sides. Now, there are some cases where you can square both sides in a situation like up here, but it doesn't always work. And because it's might be difficult to determine when it can and when it won't work, I just suggest that you just stick with separating the two parts and not trying to square both sides in this situation. That way you don't have to run into that occasional works and occasionally doesn't work situation. So this is going to be our strategy. And a little bit later, we'll also get into that sketching of the modulus graph, but it will only be linear. We're not going to get too complicated with that. These are going to be basically the main areas that Cambridge exam will focus on, is whether or not you can manage these concepts here. So let me set up for the first question. Okay, I've written it on the board, but I just want to share screen and show it to you anyway. Besides, you might be interested in the Cambridge exam code up here at the top. It tells you which year, which paper, and which number. So if you're wanting to look it up, you can see it here. So this simply just says solve the inequality. And here you see the modulus x minus 3 less than 3x minus 4, and it's worth 4 points. So let's go back to the board where we can do the work. And I've already written it up here, the modulus x minus 3 less than 3x minus 4. So when we look at it, we want to look for a couple of things. First, we want to look and see, is it one-sided or both sides? And we can see that it's a one-sided modulus. In other words, the absolute value sign is only on one side of the equation or inequality. So that means we're going to use the separated out strategy. And the second thing we want to look for is whether we have the equal sign or the inequality. And notice we have the inequality here. So that means that when we do the negative part of our separating, we need to remember to flip the inequality. So our first statement is just going to write it as you see it. For the positive statement, you don't need to change anything. So we just have x minus 3 less than 3x minus 4. And then if I can squeeze it in here, we're going to have an x minus 3. Flip the inequality, because this is going to be our negative statement, and distribute the negative through. Don't forget to distribute the negative. Don't just stick the negative at the front. It needs to distribute through. So it would be a negative 3x plus 4. So make sure to distribute the negative through that right-hand side. So this is the positive statement. This one's the negative statement. We're separating them out into the two outcomes. Now it's just a matter of solving. So if we subtract x from both of these, we get negative 3 less than 2x minus 4. Add 4, 1 less than 2x. I like to have the x in front, so I'm going to switch it around and put 2x greater than 1. So that means that x is greater than 1/2. So when we come over here, we add 3x. I like my x's positive. So add 3x, that gives us 4x minus 3 greater than 4. Add 3 to both sides, 4x is greater than 7. Here you can see this is just basic algebra. X is greater than 7/4. So now we have these, and when you get to this point, you might think you've done something wrong because both of your inequalities are facing the same direction. This actually is not uncommon. And so what we end up here is two things. And actually, if you remember over here, when you separate it out, you get a joint inequality. A joint inequality is an and statement. If you remember, maybe back in junior high, when you studied inequalities for one variable equations, and you had and or statements. And usually means that the two graphed toward each other, and or meant they graphed away from each other. Well, in this case, they're both graphing in the same direction. In fact, if you were to draw a number line, and so here's 0, here's 1/2. 1/2 is 2/4, and then 7/4. If we were to graph this, we would have an open circle graphing to the right. Let's make it a little longer than just that. And an open circle graphing to the right because it's greater than. But because this is a joint inequality, it means it's an and statement, which means both have to be true. So if you look over here at the 0, neither of them are true. If you look here in the middle, only one is true. If you look over here, both are true. So that's one way of doing it. But just in case you forget, or if you just want to make sure that that's the way it works, you can pick a test point. So the test point that you're going to want to pick is in between the two. So if this is 2/4 and this is 7/4, why don't we just pick 1, which is 4/4? And if we pick 1 and plug it back in, we get 1 minus 3 is a -2. But the absolute value of -2 is +2. Is that less than? We put 1 in over here. 3 minus 4 is -1. Is 2 less than -1? No. So that means this does not work, which means it can't be right here. So again, this is an and statement. Both of these have to be true. So only this part on the right has both of these inequality statements are satisfied. So our final answer is going to be x greater than 7/4. You do not write the x greater than 1/2. It's only x greater than 7/4, and that is the answer to this particular inequality. Okay, so let me set up the second question. Okay, for our second question, let's go to let you read it here so you can see the code if you want. Solve the inequality of absolute value of 2x minus 3 greater than 4 times the absolute value of x plus 1. So let's go back to the board. I have it written already for us. And again, first thing that we want to look at is this a one-sided or both sides with the modulus? You can see that the modulus is on both sides of the equation. So we're going to use the strategy of squaring both sides. Also, we notice that we have an inequality. So with the inequality, we're not going to have to worry about that until the end of this particular process. When you separate it, you have to worry about it at the beginning. When you're using the squares, you deal with the inequality part at the end. So what we're going to do is we're going to just go ahead, jump in and square both sides. Remember, you're squaring an entire side, not just the modulus itself. So this entire side of the equation, we're doing the same thing to both sides of our inequality. So when we square this side, we get 4x squared minus, so it'd be 12x plus 9 is greater than, you just keep the inequality the same direction. The plus and minus in the modulus doesn't matter at this point because the square makes them both positive, meaning you leave the sign the same. And here, exponents distribute to multiply. Notice the 4 is multiplying the modulus. So squares distribute to multiply. Don't forget to square that outside number. So we get 16 times x squared plus 2x plus 1. Remember that you're squaring a binomial. You cannot distribute exponents across add and subtract. So in other words, you're doing x plus 1 times x plus 1 and doing, smiley face method or FOIL method, whatever you learn to multiply out a binomial expansion. So here we have that. Now we're going to distribute the 16. So just have a little bit of writing there to do. This side stays the same. We distribute, it's 16x squared plus 32x plus 16. Now we got to decide which direction we want to go. And I like to keep my x squared or the front term positive. So here's 16x squared, here's 4. So I'm going to move everything to the right. So that means we're going to subtract 4x squared, keep everything by their place values, add 12x, and minus 9 and minus 9. So what we end up with here is 12x squared plus 44x, and then a plus 7. And notice we're on this side over here, so it has to have the pointy part facing it. So less than 0, because now all of this is canceled out on this side. All canceled. So now what we end up with is a quadratic inequality. Hopefully you remember this from the Pure 1 math book. And if you need to, you can go back. I have an entire Pure Maths 1 video series where in the first unit of quadratics, there's one of the videos covers quadratic inequalities. So with quadratic inequalities, what we want to do is we want to factor. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. We want the factors to add up to 44. They need to add to 44. Obviously, we need 1 and 7. That's a prime number. That's the only pair. And we're going to go 6 times 7 is 42 plus 2 is 44. So we're going to use this. So this comes down to 6x plus 1 and 2x plus 7 is less than 0. So let's just double check. 2x times 6x is 12x squared. 1 times 7 is 7. Here's a 2x and here's a 42x. 42 and 2 adds up to 44. So when we set each of these equal to 0, now in case you are a little rusty on your quadratic inequalities, what I do is I first set them equal to 0 to get the boundaries. Remember, inequalities deal with sets or a set of values. So in order to determine which way our set goes in the positive or negative direction, I first find that boundary between the positives and negatives, and that's the 0. So I set them equal to 0, and when I set this equal to 0, subtract 1, divide by 6. So x equals a negative 1, 6, subtract 1, divide by 6. And on this one, we get x equals a negative 7 divided by 2. So there's our two values. And what I do is I put them on a number line in order of, their value. So a negative 7/2 is actually the more negative. It's like a negative 3.5. Negative 1/6 is just slightly negative. So I put them order. Now, these are the zeros of a quadratic function, meaning if you were to graph this, you would get a quadratic graph. You know, a quadratic graph looks like a parabola. And your x squared term is positive, meaning that your graph goes like a parabola through your solutions or your zeros, and you're going to get a parabola, something like that. Doesn't have to be perfect, but it goes through. Those are your two zeros, your solutions to the quadratic that we have here. What we're looking for is whether our sets here, our areas are positive or negative. This one is above the x-axis. Here's x-axis. So the section of the graph that's above means it's positive. You plug in an x value, your y value is positive. In this section, it's negative, and over here in this section, it's positive again. So what we want to do is go back to the inequality. Remember, we said that we need to deal with the inequalities. Well, when you do the method of squaring both sides, you deal with the inequality at the end. So this is a less than 0. Less than 0 means we want the negative section. The negative section is right here in between those two values. So that means our x is here in the middle. So it is less than the negative 1/6, and it is greater than the negative 7/2. And this then is our inequality statement, our set of values that satisfy this modulus inequality. Now, be careful that your inequalities match whatever the original was. In other words, if the original has the equal to sign, make sure you keep the equal to sign all the way through. If it does not have the equal to sign, make sure that you don't include the equal to sign all the way through. If you look at Cambridge mark schemes, occasionally they'll say, you know, just ignore it and they won't count you off for it. But sometimes they say don't condone it, don't allow it, and they'll take a point off. So make sure that your inequality as far as the equal to or not equal to matches the original statement. Okay, so I notice a lot of students stop right here and they just guess when it comes to the inequalities. Don't guess. Have your mental method of figuring it out, you know, because sometimes you end up with two statements or one statement or whatever with these quadratic inequalities. So you want to make sure that your inequalities are facing the right direction. So have your method down for how to do that. Don't just stop here and guess. Most students who guess end up losing a point because they get something wrong. Okay, that was our second one. Now I'm going to set up a similar one to this, but a little bit more complicated. Okay, let's look at this next problem here and let you see what it looks like. Here it says, find the set of values of x satisfying the inequality 2 times the modulus of 2x minus a less than the modulus x plus 3a, where a is a positive constant. So when they make these little statements on the side, don't forget to refer back to that, usually at the end of your work, just to check to see if that impacts the selection that you have from your algebra. So this is similar to what we did before, except now it's got a variable in it. So let's just see how that works out. Basically, our strategy is the same. We see that there's modulus on both sides. So we're going to square both sides, which means as far as the inequality, we're not going to have to worry about that until the end of our work. So let's just jump right in and square both sides. Remember, you're squaring both sides with the inequality. And your squares, your exponents distribute to multiplication. So this is a 2 squared, which is 4 times. And when we square that out, again, remember exponents do not distribute to add or subtract. So this is really 2x minus a times 2x minus a. And we get 4x squared minus 4ax plus a squared less than x squared plus 6ax plus 9a squared. So we've squared both sides out, and we need to distribute this through. So 16x squared minus 16ax plus 4a squared less than x squared plus 6ax plus 9a squared. Remember, a is a constant and it's positive. So now let's figure out which side we want to go. We're going to subtract and move everything to this side, so we keep the x squared positive. So we're going to subtract x squared, again, keeping everything and its place value, minus 6ax minus 6ax, and a minus 9a squared minus 9a squared. So when we calculate this, we get 15x squared minus 22ax minus 5a squared is less than 0. Now we want to factor this. And don't really worry about the a squared. It functions just like this x squared does. You're going to have an x on one side, and on the other here, you'll have an a on one and a on the other. So just focus on the numbers. Here you have 1 times 5. You know we need to use that pair because it's prime. Over here, we have 1 times 15 and 3 times 5. And we're going to subtract to give us a 22. So 25 minus 3 gives us 22. 5 times 5 is 25, minus 3 is our 22, and we want the larger one to be negative. So we're going to have 5x, we're going to have a 3x, and our 5 needs to be multiplying by 5 over here, and it's the larger one, it needs to be negative. So this one will be positive, and this one is going to be just 1. So let's double check. We need the a's. Let's not forget to put the a's in. So 5x times 3x is 15x squared. 1a times a negative 5a is a negative 5a squared. Here we have a negative 25ax plus 3ax gives us a negative 22ax. Okay, now we can again, I'm going to solve it equal to 0 first to identify the boundaries. So here we get x equals a negative a over 5. So subtract a, divide by 5. And here we're going to get x equals 5a divided by 3. And we want to find the section that is less than 0. We want the negative section of our graph. So if we draw a number line, put them in order. So here's a negative. Notice it says a is positive. Okay, so we don't have to worry about, well, what depends on what a is as to which one's bigger or smaller. Since a is positive, this is going to end up being negative. And since a is positive, this one's going to end up being positive. 5a over 3. And if we draw our parabola through that, because our x squared term is positive, means the parabola is facing up. So those are the two solutions or zeros in the graph. And we can see our positive, negative, and positive above or below the x-axis. Okay, that's our point of reference. And this wants the negative section, which is right in between. So our value of x, our set of values, and again, keep your inequality without the equal sign. If it has the equal sign in the original, make sure to include it on both your inequalities. This one does not have it. So x will be less than 5a over 3 and greater than negative a over 5. It's right in between those two values. And so here is our solution set. And it just happens to have the variable a in it. So you don't have to get the exact numeric value. You have the values, but in terms of a. So it worked just like the last one did. Okay, let's go to one more question where we'll get into a little bit of sketching and also an inequality that goes with it. Okay, let's look at our last question that we have here. If you notice, our last question has a two-part question here. And if you look at the coding, the SP, this is from the specimen paper. The reason why I took from the specimen paper is because the graphing part is new material to the 2020 syllabus cycle. And so it wasn't in the previous books or past papers. So that's why I took from the specimen paper. Also, I noticed from the May-June 2020 series that came out, that they didn't have modulus in 2 out of the 3 test papers. They only had it in 1 of them, and it didn't include graphing. So that's a little curious to me. I kind of expected a little bit more of graphing because it is in the new material, but we'll still cover it so that you're ready for it when it does happen. Notice it says sketch the graph of y equals absolute value 2x minus 3, and then it gives us an inequality to solve 3x minus 1 greater than the absolute value of 2x minus 3. So this is what we're going to work with here, and we'll start with the graphing, and let's get back to our board. I've already got it written here on the board. So what we want to do with, notice we're going to sketch this graph, and this is a one-sided modulus, and it's linear, so it's not that complicated. We will split it up into the 2 parts. The positive part is y equals 2x minus 3, and then the negative part, y equals, you don't have to worry about flipping it because it's an equal sign, not an inequality. But you do have to remember to distribute the negative on the other side. So you get a negative 2x plus 3. Okay, so this is our 2 different graphs. We're going to draw it on 1 graph paper here. Just make it, doesn't have to be perfect, it's a sketch. Now, if you notice, this one has a y-intercept of -3. 1, -2, -3. And it goes up 2 over 1. It's going to go up basically here. And we're going to find out that it crosses right here as you draw this line through. It's going to go up like this. And the way we can find this point right here is this is our x-axis, meaning that y is 0. If you're on the x-axis, the y value is 0. So if we plug in a 0 for y, you're going to end up with x equaling positive 3 halves. Positive 3 halves is where I put the dots at 1.5. And the reason why I drew this part solid and this part dotted is because this is a modulus. Modulus is the positive part of the graph, which is the part that's above the x-axis. So this other part is just to help guide me because we're used to the y equals mx plus c, and that plus c is the y-intercept. If we go to this one, it's crossing the y-axis at positive 3, 2, 3. And has a slope of -2 over 1 down 2 over 1. And so it's going to come down here to this point right here. And notice it will also come through this. If you make this 0, again, if you make your y value 0, you subtract 3 and divide by a -2, you still get y equals 3 halves. Both ways, you end up with that same point, and it ends up becoming the vertex of your graph. So this is the section that is positive. Remember, absolute value gives you positive outcome. And so this other part down here, you can just erase those. I mean, the line would go on that way, but we want the absolute value part. I'm just going to erase this dotted part. This part that we have left is our sketch for this. So it's not really too difficult. Just make your 2 statements, just like we did before with a one-sided inequality. And if you want to solve for where that vertex is at by making y 0, because that's your x-axis, y equals 0, and solve, and you get your vertex in your graph. Okay, so that's how we graph it. That's the new material in the 2020 syllabus. Now let's go down here just to review what we did at the very beginning in the first problem. So we look at it and see this is a one-sided. So we need to write it as two separate statements. Now this side is the absolute value side. There's a couple ways you can do it, but I like to think from the absolute value. So 2x minus 3, and notice the pointy is facing that, so less than 3x minus 1. We don't change anything. Then we take our 2x minus 3. Now for the negative one, we flip the inequality so it becomes greater than, flipping it this way. So we're reading it from here. So instead of less than, it's now a greater than. And we distribute the negative. So minus 3x plus 1. So don't forget to distribute the negative. Then we solve from here. So if we subtract 2x plus 3, we get, actually, sorry, we want to have x on one side and the values on the other. So let's just do this first. So we're going to get an x minus 1 greater than negative 3. I like to put x positive and in the front. So I kind of flipped us around again. And then add 1. So add 1, x is greater than negative 2. Over here, add 3x, 5x minus 3 is greater than 1. Add 3, 5x is greater than 4. X is greater than 4/5. Now here we have our two inequalities, and notice again they're facing the same direction. If you put them on a number line here, can you see that at the bottom? Make sure you can see that there. If we put that on a number line, the negative 2 is over here. It is going in the greater than direction. The 4/5 is positive, it's over here. It's going that way. So remember, we're going to want the and part because it's a you can make it a joint inequality, like what we saw over here. These are joint inequalities, which means it's an and statement. If you forget, then just pick a number in between them. So you get 0. 0 is in between negative and positive. If you plug in 0 right here, you get absolute value of negative 3 is 3. If you plug in 0 over here, you get a negative 1. So is negative 1 greater than 3? No, it's not. So you can't include this part. So it's only this part over here. So our final answer is x greater than 4/5. Okay. So what you want to do now that we're starting the Pure Math 3 video series, as you go through, focus on the concept and especially these little strategies that can help you differentiate what you need to do within that question type. And then also focus on the details in your mechanics and execution of your algebraic procedure. And so thank you for joining me, and hope to see you again next time in the Zoom room for part 2, which will be polynomials.